Well, how are you doing? Okay, this is a video that's going to be responding to the strawman argument that we keep on getting from our opposition on the ball side. Right? It's a very pathetic strawman argument. It's a very dishonest strawman argument, and it actually kills them. And I don't know what technically it kills them because they admit to the right angle triangle. But look, we're dealing with people who are not not honest most of the time, or they're just not logical. They can't think logically. Okay, the argument is that in celestial navigation, you have the observer, you have the celestial body here, and you have the GP point, right? What I'm going to point out in this video is, right, and please put this in the comments. It was pointed out by Adam Meakin, right? So if you're going to thank anyone in the comments, thank Adam Meakin. I'm making a video. Adam Meakin pointed out to a bowler who was attacking us on Nathan's some while back, and the bowler had no comeback because Adam just pointed out something very obvious. When we take, let's say, the elevation angle, right, to a celestial body in celestial navigation, or when someone does it, not we, I don't do it, but when someone does do it, right, there's a claim from the ball side that they're not using a right angle triangle. The ball side wants to just believe that they only have an adjacent and a hypotenuse. But it's a vertical measurement, angular measurement. So how could they not be using an opposite? And when they rock the sextant, the whole point of rocking the sextant is to set the zenith from the GP point to the celestial body. So they have two parallel zeniths, their own one here, and the zenith from the GP to the celestial body. That means there's an equal distance all along both zeniths between each other because they're parallel. Right? Now they want to deny that because they're bozos, but what can you do? But what they try and do to overcome the fact that an elevation angle is a right angle triangle, whether it be surveying, astronomy, aerospace, or celestial navigation, it's always a right angle triangle because it's a measurement of a vertical height, right? An angular vertical height. That's what you're measuring. I don't understand why they can't get this. It's obviously beyond their ability to understand, right? Like a lot of things, they don't know what they're talking about till Flat Earther teaches them, and then they're suddenly experts in it. Unbelievable. But anyway, long story short, what they do is, let's just say this is 62.198 degrees, right, of an elevation angle, right? And we determine, based off of that elevation angle, we determine the adjacent length, right? So let's say, right, so as it, right, so 62.1984, let's just say 1984, right? Multiplied, subtracted from 90 will give us this equals, right? Basically this number up there, right? And then we multiply that by 60, right? And it'll give us 1668, right? That's 1,668 nautical miles. That's the length along this blue line down here, right? Based off of that elevation angle. So what the ballers will do at this point is they'll say, how come you don't know the height of the celestial body then? Because you're claiming a right angle triangle. We're not claiming a right angle triangle. We're pointing out, right, that an elevation angle is a right angle triangle. You're measuring a vertical angular height. That's what it is. An elevation angle is always a right angle triangle. It doesn't matter what the process used, whether it be surveying type process with trigonometry or a process in celestial navigation using parallel zeniths, you're still using a right angle triangle. But they want to, at this point, after we've gotten the adjacent length, the ballers then, right, what they want to do then is they want us to tell them what height the celestial body is, right? So what's this? So 1668096, right? So right, so 1668.096, right? That's, and the angle is 62 point whatever. What is the angle? 60 62.198. Right, we'll just go with that. So angle A, right, 62.198, right, and calculate. Right, so we'll just go up here. Make it a bit bigger. Right. So here is the results. Right. That means that A, right, is 3,163. So using this adjacent length, according to the ballers, that means that the height of the celestial body should be 3,163 miles. Now, they, right, this is something I had to point out to them in a rebuttal to the rubbish they were coming out with a few years ago, that when this angle here changes, which it will, whether the observer moves or the celestial body moves, then this will happen, right, for the observer, because this is a perspective view measurement. So for the observer, the celestial body will either appear to get lower towards the horizon or get higher above the horizon. So consequently, when the angle changes, when the angle here changes in reality, right, when this part changes, then for the observer, this part changes, right? And the story, right? So, right, for the observer in reality, because you're not using it in the way it's not going to. It will stay here, right? But in reality, it'll stay wherever height is at. But for the angle for the observer will change. So if it's here and if it's here and we determine we get the adjacent length here, and then we determine the opposite length to give us a height of the celestial body, then an hour later it's here. So that gives us. Then we have to use a completely different. We have a completely different height to the celestial body, because the celestial body is not going to is for the observer going to appear to change, because we have a different angle now. So based off of this length here that we'll have to work out from our elevation angle, right? This opposite side has now changed, right? Even right, the opposite side will have changed for the observer. So that means that every time that angle, the elevation angle changes, the calculated height to the celestial body, because you don't know, the calculated height to the celestial body is going to change. So you can't find out the height of the celestial body. Now I had to point that out to the ballers a couple of years ago. They didn't understand that. And what they did is they took that very argument that I pointed out to them, and they ran with that and tried to make it their own, like they always do. They try and, they're not an original. They're always coming up with nonsense that they had to borrow or hijack from somewhere else, often from flat earthers. So they thought that was some kind of rebuttal. But Adam Meakin pointed out something important and very, very obvious. He's like, when you're doing trigonometry, right? If you're going to do trigonometry, you from this exact position where the observer is, you don't have a length of side. To get the length of side, you must go through this one here. You must go through the celestial navigation process of taking the angle and the elevation angle, and then you subtract it from the zenith angle, or from 90 to get your zenith angle, which would be 37. So if it's 52.5, it'll be 37.4, and then you multiply the 37.4 by 60, and that gives you the length of the adjacent, right? So once you do all that, you then have a side length. So why would you be then using trigonometry after that? The whole point of the process is to get horizontal distance between the observer and the GP point. That's the point of the process. So why would you be doing that after that? Especially as the apparent height of the celestial body is going to continually change as your apparent angle to it, right, keeps changing. Right, your angle to it keeps changing. Well, the angle, I suppose, is not exactly apparent, but once your angle changes, then the calculated height will change. The whole lot will keep changing, no matter what you do. So why would you be then doing that? That makes absolutely no sense. So from a trigonometry point of view, as Adam Meakin pointed out to this baller, well, all you actually have from a trigonometry point of view, if you're starting off with trigonometry, if you just start with trigonometry, overcoming a chest problem. If you just start with trigonometry, then technically all you have is 3 internal angles. So you have 50.527 here, 39.472 there, and 90 here. How are you going to find out the length of those sides, or your distance from the GP point, with just 3 internal angles? You'll never be able to figure it out, because you can never know the length of the sides with just 3 internal angles. So when the next time one of the ballers wants to ask you, what's the height of the celestial body, considering you're claiming a right angle triangle? We're not claiming right angle triangles. We're pointing out that that's what elevation angles are. They're right angle triangles. That's how they're defined. Because you're measuring, listen to this, ballers, a vertical angular height. Vertical, the opposite. That's what you're measuring. That's what they get. This is the zenith that they get with the rocking of the sextant. This here, the thing that you're all denying, that's what you're doing. You're measuring that. So the point being is that if they're claiming trigonometry, why are they bringing it in after they get that side length, after the adjacent? Why would you be doing it after that? That's what you're looking to get. So if they're trying to claim that when we point out that the celestial navigation elevation angles, that all elevation angles are right angle triangles, but they don't use trigonometry in celestial navigation, when they're trying to straw man us with that, sorry, you with that, ask them where are they getting the side length from, because to get that they have to go through the celestial navigation process. They can't go through that. If they're claiming that we're claiming trigonometry, which we're not, then ask them how are they going to get the side lengths with just 3 internal angles. Ask them how they're going to get that, because you can't get the side lengths from just 3 internal angles, as Adam pointed out. Ask them where they're going to get that from. They can't get that, because that's all they have. They don't have a side length until after they've gone through the celestial navigation process. Until that happens, they don't have a side length. Because you must know, right? You must know either either the height of the object, right, to figure your distance from it, right, with trigonometry, or you must know your distance from the object to figure the height of it, right, based off of the angle. Now, if you're talking about trigonometry, you're starting off, right, without this length, because you don't know that. So why would you be going through the process of celestial navigation to get that, and then do trigonometry to get a celestial body height that is not going to be constant, that's going to change as soon as this changes? Why would you be doing that? You wouldn't be doing it. But what you would be doing is measuring a vertical angular height to a celestial body, and then using the celestial navigation process to determine your adjacent length. That's what you would be doing. You would not be doing trigonometry after that. So if they want to try and strawman you with this trigonometry nonsense, ask them how are they going to get the length of sides with three internal angles and no side lengths. How are they going to figure out that? Because that's what they're claiming. That's what they're claiming when they're bringing up trigonometry, right? They must first go through the celestial navigation process to have an adjacent length, to then try and strawman you with. Why would you be doing that after that? That's the thing you're looking to know. You're not looking to know the length of the hypotenuse or the length of the opposite. You know they're there, but you're not looking to use them because they can't be used, right? They can't be used as a constant. You can't, this is not going to stay constant. As soon as this angle here changes, then the apparent height of the celestial body is going to change. So why would you be doing that? Celestial navigators don't claim a height of the celestial bodies. Even astronomers don't. Even astronomers generally, right, when they're doing what they're doing, they don't claim a height or distance to it. It's afterwards there's a height distance claimed. Nobody's claiming heights and distances to the celestial bodies in celestial navigation. So why would flat earthers need to do it when flat earthers don't claim a height to the celestial bodies? All they're claiming is that celestial navigation is measuring horizontal distances along the surface of Earth. And in the Nautical Almanac, as I've pointed out and I've actually shown before, is that the site reduction tables, right, pre-assume that the adjacent is sea level. That's why I have it in blue here. So mean sea level is your adjacent. So it's the Nautical Almanac pre-assumes for site reduction tables which correct, right, your elevation angle, make it more precise. The Nautical Almanac is pre-assuming that mean sea level is your horizontal. And that could be for thousands of miles. So, that's all you're looking to know. You're looking to know that. You don't need to know the height of the celestial body. So why would you be doing trigonometry after that? So if they want to claim trigonometry, tell them Okay, then here's 3 internal angles. Figure out the sides. Because that would be a fair response to that complete and utter rubbish strawman argument that they have. Because that's all they have. A load of tactics and strawman arguments and lies and nonsense and the robbery of other people's ideas, because that's all they're good for. They're not original. They're just bozos. There's no way around it. They're just bozos. Check out the comments in all my videos. Check them out. Watch the videos and check them out. If you don't understand some of what's going on in the video, go through it, find out, and then come back and read the comments. They're idiots. It's unbelievable. The only reason that they're still in this argument against us is because they're too stupid to realise that they lost. It's that simple. They're too stupid to realise that they don't have an argument. That's the only way. That's where I'm left with. 99% of them, right? They're too stupid to realise. There's a certain percentage of them that are pretty smart, but 99% of them, they're too stupid to realise it. They don't realise the argument's over. They don't realise that they don't have an argument. They never even know when they're walking into their own traps. It's just ridiculous. So I don't know how someone could not understand that when you're looking to know this and you figure it out, that you wouldn't be looking to know that. Why would you be looking to know that? That's just ridiculous. I don't understand why they think that we would then have to know that. It's just, why are you so stupid, Paul? Why are you so stupid? I don't get it. Why can't you understand basic things? This is another thing. Why can't they understand the difference between orthographic and perspective view? Why can't they understand that? Perspective view is not orthographic. Do you know what I mean? You can't, why can't you understand the difference between those two things? I don't understand. It's beyond me. But look, this is what we're dealing with. Ask them to come up with their length of sides with just 3 internal angles. Tell them they're not allowed to use celestial navigation to get the length of the adjacent. No, can't use that. We need the length of the sides, because you're claiming that we're claiming trigonometry. Okay, then how would you figure those side lengths out with just those 3 internal angles? How would you do that? Considering you're claiming it, because we're not claiming trigonometry, you're claiming it. So we can give you a length. We can give you this length using right angle triangles, but not using trigonometry. What have you got? Nothing. Nothing. They don't even have this, because they don't have a horizontal baseline. They're bozos. Thanks for watching.